Okay, let's talk about section 5.1, which is called probability distributions. This first section is super easy, so I'm gonna go through the PowerPoint really quick and do a couple of problems. A random variable is a variable whose values are determined by chance. There's two types, discrete and continuous, and we've already talked about those. A discrete probability distribution consists of the values that a random variable can assume and the corresponding probabilities. Okay? All right, let's do a couple of problems. So let me get my stuff up. If you'll get your book and turn to page, let's see, 263. 263. Okay. All right, let me do this. Okay. Sorry about that. All right, if we go back to page 263 and we look at number 7. If something is a true probability distribution, the probabilities will add to 1. So if we look at number 7, it says determine whether the distribution represents a probability distribution. If it does not, state why. Okay, so if you did number 7, you're going to take the probabilities, which is 0.3, add them up, plus 0.5, plus 0.7, plus negative 0.8, okay? And if those add to 1, it is a probability distribution. If they don't add to 1, it is not. If you punch these in and add, I think they add to 0.7, okay? Which is obviously not 1, so therefore this is not a true probability distribution. Okay? If you wanted to check number 9 does add to 1, and number 10 does not. Okay, moving on. Let's look at 13. Alright, this is stuff we've already talked about. Number 13 says, decide whether it's discrete or continuous. 13 says the number of cheeseburgers a fast food restaurant serves. You can count that, so it's discrete. Okay, 15. The weight of an automobile. Anything that can be measured is continuous. It's ever changing. 17. The number of math majors in your school. You can count that, so that's discrete. Okay, I'm going to do one more problem with y'all, and I think we'll be good. Let's do number 19. The directions say, construct the probability distribution for the data and draw a graph. So, all that means is we're going to make a table with the x values and the probabilities that correspond to those. So if I'm looking at 19, the probability that a patient will have 0, 1, 2, or 3 medical tests, those are my x's. Okay. Performed on entering a hospital, or 6/15. Don't reduce those because you're going to see why. 5/15, 3/15, and 1/15. Okay. All right. What we're going to do now is draw something that looks like a bar graph. This is going to be your probabilities. Okay. And this is going to be your number of tests. So across the bottom, I have 0, 1, 2, and 3. And my probabilities, now I want to count in even increments. So this is my largest, So I could count by twos or whatever you wanted to. 2/15, 4/15, 6/15. Okay, you could go larger than you wanted, you could go smaller increments, it's whatever. So 0 is 6/15, I'll draw a bar up to that. 1 is 5/15, so kind of estimate where that is. 2 is 3/15, and 3 is 1/15. So that's just what a probability distribution looks like. And that's pretty much this whole section.